Welcome, ladies and gentlemen, to our discussion about predicting the products of a reaction, specifically single replacement reactions. If we are going to guess what the products will be, we need to think about the pattern of what happens during a single replacement reaction. Now, in this type of reaction, you will have a single element. Notice down here in the examples, calcium is an element, reacting with some type of compound. Here we have an ionic compound with lithium and chlorine, which would be lithium chloride. We have to decide if the singleton, which is the element in the reactants, so in this case it would be the calcium, is a metal or a non-metal. That helps us decide what it is going to switch with. So if it's a metal, it's going to trade partners with the metal in the compound. If the substance is a non-metal, it will trade partners with the non-metal in the compound. So let's look at our example here with calcium and lithium chloride. Calcium would be a metal. It is in the second group or second column on the periodic table. That means it's going to trade places with the lithium in the compound. So I need to consider the charge on the ions when I make this switch. Cl makes a -1 because it's in column 7, and Ca would make a 2+ because it's in column 2. So that would mean I need to have the formula of CaCl2 to cancel out my charges. Let's get that extra work out of the way. Then all that's left would be my elemental form of lithium. The final step would be to balance the equation. Anytime I finish my formulas, the last step is to balance the equation. So you'll notice here, I have one Ca on the left and one on the right, one Li on the left and one on the right, but two Cls on the right. So I need a coefficient of 2 on the left. That has now changed my lithiums, so then I need to finish with a 2 over here. That has balanced my equation. Next, let's take a look at the sodium and the aluminum carbonate. Sodium would be a metal. It's in column 1. That means it's going to trade places with the aluminum, the other metal in the compound. Let's move this out of the way. Sodium is a +1. The CO3, the carbonate, is a 2-. So that means I have a formula of Na2CO3, and then my aluminum would be left over as the element. Last step, I need to balance my equation. So I see right now, the easiest one to start with would be the CO3 because it's the thing that's in a compound on both sides. I have 3 on the left, so I need to put a 3 here to get 3 carbonates on the right. That gives me 6 sodiums. So I need to put a 6 over here. And then the 2 that I see right here means I need 2 aluminums here. Balanced and done. Our last equation, we have iodine combining with lithium sulfide. Iodine is a non-metal, which means it's going to trade places with the non-metal in the compound. The iodine and the sulfur will switch. So lithium is a +1. Iodine is a -1, so that means my formula would simply be LiI. And that would leave sulfur as the remaining element. It is not a Hofbrinkel element, so S is my formula. Last step would be to balance. I see 2 Li's on the left. I'm going to go 2 Li's here, and then that's great because that balances out the 2 that I had over here for the iodine as well. So you have to consider metal or non-metal, make the trade, then finish by balancing. You can now download the document to do the practice and check the answer key.